Chip Huyen AI Engineering Building Applications with Foundation Models. 9781098166304579999 ISBN 978-1-098-16630-4 US $79. 99 can $99. 99 data foundation models have enabled many new AI use cases while lowering the barriers to entry for building AI products. This has transformed AI from an esoteric discipline into a powerful development tool that anyone can use, including those with no prior AI experience. In this accessible guide, author Chip Huyen discusses AI engineering, the process of building applications with readily available foundation models. AI application developers will discover how to navigate the AI landscape, including models, datasets, evaluation benchmarks, and the seemingly infinite number of application patterns. The book also introduces a practical framework for developing an AI application and efficiently deploying it. Understand what AI engineering is and how it differs from traditional machine learning engineering. Learn the process for developing an AI application, the challenges at each step, and approaches to address them. Explore various model adaptation techniques, including prompt engineering, RAG, fine-tuning, agents, and dataset engineering, and understand how and why they work. Examine the bottlenecks for latency and cost when serving foundation models and learn how to overcome them. Choose the right model, metrics, data, and developmental patterns for your needs. AI engineering. This book offers a comprehensive, well-structured guide to the essential aspects of building generative AI systems. A must-read for any professional looking to scale AI across the enterprise. Vittorio Cretella, former global CIO at P&G and Mars. Chip Huyen gets generative AI. She is a remarkable teacher and writer whose work has been instrumental in helping teams bring AI into production. Drawing on her deep expertise, AI engineering is a comprehensive and holistic guide to building generative AI applications in production. Luke Metz, co-creator of ChatGPT, former research manager at OpenAI. Chip Huyen works at the intersection of AI, data, and storytelling. Previously, she was with Snorkel AI and NVIDIA, founded an AI infrastructure startup, acquired, and taught machine learning systems design at Stanford. Her book Designing Machine Learning Systems, O'Reilly, has been translated into over 10 languages. Praise for AI engineering. This book offers a comprehensive, well-structured guide to the essential aspects of building generative AI systems. A must-read for any professional looking to scale AI across the enterprise. Vittorio Cretella, former global CIO, P&G, and Mars. Chip Huyen gets generative AI. On top of that, she is a remarkable teacher and writer whose work has been instrumental in helping teams bring AI into production. Drawing on her deep expertise, AI engineering serves as a comprehensive and holistic guide, masterfully detailing everything required to design and deploy generative AI applications in production. Luke Metz, co-creator of ChatGPT, former research manager at OpenAI. Every AI engineer building real-world applications should read this book. It's a vital guide to end-to-end AI system design, from model development and evaluation to large-scale deployment and operation. Andrei Lopatenko, Director Search and AI, Neuron 7. This book serves as an essential guide for building AI products that can scale. Unlike other books that focus on tools or current trends that are constantly changing, Chip delivers timeless foundational knowledge. Whether you're a product manager or an engineer, this book effectively bridges the collaboration gap between cross-functional teams, making it a must-read for anyone involved in AI development. Aileen Bui, AI Product Operations Manager, Google. This is the definitive segue into AI engineering from one of the greats of ML engineering. Chip has seen through successful projects and careers at every stage of a company and for the first time ever condensed her expertise for new AI engineers entering the field. SWYX, Curator, AI. Engineer AI Engineering is a practical guide that provides the most up-to-date information on AI development, making it approachable for novice and expert leaders alike. This book is an essential resource for anyone looking to build robust and scalable AI systems. Vicky Raiselman, Chief AI Solutions Architect, Maeve Sparks. AI Engineering is a comprehensive guide that serves as an essential reference for both understanding and implementing AI systems in practice. Han Lee, Director, Data Science, Moody's AI Engineering is an essential guide for anyone building software with generative AI. It demystifies the technology, highlights the importance of evaluation, and shares what should be done to achieve quality before starting with costly fine-tuning. Rafal Kawala, Senior AI Engineering Director, 16 years of experience working in a Fortune 500 company. Chip Huyen AI Engineering Building Applications with Foundation Models. 978-1-098-16630-4, LSI, AI Engineering by Chip Huyen. Copyright 2025 Developer Experience Advisory LLC. All rights reserved. Printed in the United States of America. Published by O'Reilly Media Incorporated, 1005, Gravenstein Highway North, Sebastopol, California, 95472. O'Reilly books may be purchased for educational, business, or sales promotional use. Online editions are also available for most titles. http://O'Reilly.com. For more information, contact our corporate/institutional sales department, 800-998-9938 or corporate@O'Reilly.com. Acquisitions Editor, Nicole Butterfield. Indexer, WordCo Indexing Services Incorporated. Development Editor, Melissa Potter. Interior Designer, David Furtado. Production Editor, Beth Kelly. Cover Designer, Karen Montgomery. Copy Editor, Liz Wheeler. Illustrator, Kate Dullia. Proofreader, Piper Editorial Consulting, LLC. December 2024, First Edition Revision History for the First Edition December 4, 2024, First Release. See http://O'Reilly.com/catalog/errata. CSP? ISBN equals 9781098166304 for release details. The O'Reilly logo is a registered trademark of O'Reilly Media Incorporated. AI Engineering, the cover image, and related trade dress are trademarks of O'Reilly Media Incorporated. The views expressed in this work are those of the author and do not represent the publisher's views. While the publisher and the author have used good faith efforts to ensure that the information and instructions contained in this work are accurate, the publisher and the author disclaim all responsibility for errors or omissions, including without limitation responsibility for damages resulting from the use of or reliance on this work. Use of the information and instructions contained in this work is at your own risk. If any code samples or other technology this work contains or describes is subject to open source licenses or the intellectual property rights of others, it is your responsibility to ensure that your use thereof complies with such licenses and/or rights. Table of Contents. Preface. 11.1. Introduction to Building AI Applications with Foundation Models. 1. The rise of AI engineering. 2. From language models to large language models. 2. From large language models to foundation models. 8. From foundation models to AI engineering. 12. Foundation model use cases. 16. Coding. 20. Image and video production. 22. Writing. 22. Education. 24. Conversational bots. 26. Information aggregation. 26. Data organization. 27. Workflow automation. 28. Planning AI applications. 28. Use case evaluation. 29. Setting expectations. 32. Milestone planning. 33. Maintenance. 34. The AI engineering stack. 35. 3 layers of the AI stack. 37. AI engineering versus ML engineering. 39. AI engineering versus full stack engineering. 46. Summary. 47b. Understanding foundation models. 49. Training data. 50. Multilingual models. 51. Domain-specific models. 56. Modeling. 58. Model architecture. 58. Model size. 67. Post-training. 78. Supervised fine-tuning. 80. Preference fine-tuning. 83. Sampling. 88. Sampling fundamentals. 88. Sampling strategies. 90. Test time. Compute. 96. Structured outputs. 99. The probabilistic nature of AI. 105. Summary. 111.3. Evaluation methodology. 113 Challenges of evaluating foundation models. 114 Understanding language modeling metrics. 118 Entropy. 119 Cross entropy. 120 Bits per character and bits per byte. 121 Perplexity. 121 Perplexity interpretation and use cases. 122 Exact evaluation. 125 Functional correctness. 126 Similarity measurements against reference data. 127 Introduction to embedding. 134 AI as a judge. 136 Why AI as a judge. 137 How to use AI as a judge. 138 Limitations of AI as a judge. 141 What models can act as judges? 145 Ranking models with comparative evaluation. 148 Challenges of comparative evaluation. 152 The future of comparative evaluation. 155 Summary. 156 6 Table of contents. Evaluate AI systems. 159 Evaluation criteria. 160 Domain-specific capability. 161 Generation capability. 163 Instruction following capability. 172 Cost and latency. 177 Model selection. 179 Model selection workflow. 179 Model build versus buy. 181 Navigate public benchmarks. 191 Design your evaluation pipeline. 200 Step 1. Evaluate all components in a system. 200 Step 2. Create an evaluation guideline. 202 Step 3. Define evaluation methods and data. 204 Summary. 208 5. Prompt engineering. 211 Introduction to prompting. 212 In context learning. Zero shot and few shot. 213 System prompt and user prompt. 215 Context length and context efficiency. 218 Prompt engineering best practices. 220 Write clear and explicit instructions. 220 Provide sufficient context. 223 Break complex tasks into simpler subtasks. 224 Give the model time to think. 227 Iterate on your prompts. 229 Evaluate prompt engineering tools. 230 Organize and version prompts. 233 Defensive prompt engineering. 235 Proprietary prompts and reverse prompt engineering. 236 Jailbreaking and prompt injection. 238 Information extraction. 243 Defenses against prompt attacks. 248 Summary. 251 6. RAG and agents. 253 RAG. 253 RAG architecture. 256 Retrieval algorithms. 257 Retrieval optimization. 267 Table of contents. 7. RAG beyond texts. 273 Agents. 275 Agent overview. 276 Tools. 278 Planning. 281 Agent failure modes and evaluation. 298 Memory. 300 Summary. 305 7. Fine-tuning. 307 Fine-tuning overview. 308 When to fine-tune. 311 Reasons to fine-tune. 311 Reasons not to fine-tune. 312 Fine-tuning and RAG. 316 Memory bottlenecks. 319 Backpropagation and trainable parameters. 320 Memory math. 322 Numerical representations. 325 Quantization. 328 Fine-tuning techniques. 332 Parameter efficient fine-tuning. 332 Model merging and multitask fine-tuning. 347 Fine-tuning tactics. 357 Summary. 361 8. Dataset engineering. 363 Data curation. 365 Data quality. 368 Data coverage. 369 Data quantity. 372 Data acquisition and annotation. 377 Data augmentation and synthesis. 380 Y data synthesis. 381 Traditional data synthesis techniques. 383 AI-powered data synthesis. 386 Model distillation. 395 Data processing. 396 Inspect data. 397 Deduplicate data. 399 Clean and filter data. 4018 Table of contents. Format data. 401 Summary. 4039 Inference optimization. 405 Understanding inference optimization. 406 Inference overview. 406 Inference performance metrics. 412 AI accelerators. 419 Inference optimization. 426 Model optimization. 426 Inference service optimization. 440 Summary. 447 10 AI engineering architecture and user feedback. 449 AI engineering architecture. 449 Step 1. Enhance context. 450 Step 2. Put in guardrails. 451 Step 3. Add model router and gateway. 456 Step 4. Reduce latency with caches. 460 Step 5. Add agent patterns. 463 Monitoring and observability. 465 AI pipeline orchestration. 472 User feedback. 474 Extracting conversational feedback. 475 Feedback design. 480 Feedback limitations. 490 Summary. 492 Epilogue. 495 Index. 497 Table of contents. 9. 1 An author of the AlexNet paper, Ilya Sutskever, went on to co-found OpenAI, turning this lesson into reality with GPT models. 2 Even my small project in 2017, with which used a language model to evaluate translation quality, concluded that we needed a better language model. Preface: when ChatGPT came out, like many of my colleagues, I was disoriented. What surprised me wasn't the model size or capabilities. For over a decade, the AI community has known that scaling up a model improves it. In 2012, the AlexNet authors noted in their landmark paper that, all of our experiments suggest that our results can be improved simply by waiting for faster GPUs and bigger datasets to become available. 2. What surprised me was the sheer number of applications this capability boost unlocked. I thought a small increase in model quality metrics might result in a modest increase in applications. Instead, it resulted in an explosion of new possibilities. Not only have these new AI capabilities increased the demand for AI applications, but they have also lowered the entry barrier for developers. It's become so easy to get started with building AI applications. It's even possible to build an application without writing a single line of code. This shift has transformed AI from a specialized discipline into a powerful development tool everyone can use. Even though AI adoption today seems new, it's built upon techniques that have been around for a while. Papers about language modeling came out as early as the 1950s. Retrieval augmented generation, RAG, applications are built upon retrieval technology that has powered search and recommender systems since long before the term RAG was coined. The best practices for deploying traditional machine learning apply cations, systematic experimentation, rigorous evaluation, relentless optimization for faster and cheaper models, are still the best practices for working with foundation model-based applications. The familiarity and ease of use of many AI engineering techniques can mislead people into thinking there is nothing new to AI engineering. But while many principles for building AI applications remain the same, the scale and improved capabilities of AI models introduce opportunities and challenges that require new solutions. This book covers the end-to-end process of adapting foundation models to solve real-world problems, encompassing tried-and-true techniques from other engineering fields and techniques emerging with foundation models. I set out to write the book because I wanted to learn, and I did learn a lot. I learned from the projects I worked on, the papers I read, and the people I interviewed. During the process of writing this book, I used notes from over 100 conversations and interviews, including researchers from major AI labs, OpenAI, Google, Anthropic, framework developers, NVIDIA, Meta, Hugging Face, Anyscale, LangChain, Llama Index, executives and heads of AI/data at companies of different sizes, product managers, community researchers, and independent application developers. See acknowledgements on page XX. I especially learned from early readers who tested my assumptions, introduced me to different perspectives, and exposed me to new problems and approaches. Some SEC tie-ins of the book have also received thousands of comments from the community after being shared on my blog, many giving me new perspectives or confirming a hypothesis. I hope that this learning process will continue for me now that the book is in your hands, as you have experiences and perspectives that are unique to you. Please feel free to share any feedback you might have for this book with me via X, LinkedIn, or email at hi@huyenchip.com. What this book is about: this book provides a framework for adapting foundation models, which include both large language models, LLMs, and large multimodal models, LMMs, to specific applications. There are many different ways to build an application. This book outlines various solutions and also raises questions you can ask to evaluate the best solution for your needs. Some of the many questions that this book can help you answer are: should I build this AI application? How do I evaluate my application? Can I use AI to evaluate AI outputs? What causes hallucinations? How do I detect and mitigate hallucinations? What are the best practices for prompt engineering? Why does RAG work? What are the strategies for doing RAG? 12. Preface. 3. Teaching a course on how to use TensorFlow in 2017 taught me a painful lesson about how quickly tools and tutorials become outdated. What's an agent? How do I build and evaluate an agent? When to fine-tune a model? When not to fine-tune a model? How much data do I need? How do I validate the quality of my data? How do I make my model faster, cheaper, and secure? How do I create a feedback loop to improve my application continually? The book will also help you navigate the overwhelming AI landscape, types of models, evaluation benchmarks, and a seemingly infinite number of use cases and apply cation patterns. The content in this book is illustrated using case studies, many of which I worked on, backed by ample references and extensively reviewed by experts from a wide range of backgrounds. Although the book took 2 years to write, it draws from my experience working with language models and ML systems from the last decade. Like my previous O'Reilly book, Designing Machine Learning Systems, DMLS, this book focuses on the fundamentals of AI engineering instead of any specific tool or API. Tools become outdated quickly, but fundamentals should last longer. 3. Reading AI Engineering, AIE, with Designing Machine Learning Systems, DMLS, AIE can be a companion to DMLS. DMLS focuses on building applications on top of traditional ML models, which involves more tabular data annotations, feature engineering, and model training. AIE focuses on building applications on top of Foundation models, which involves more prompt engineering, context construction, and parameter-efficient fine-tuning. Both books are self-contained and modular, so you can read either book independently. Since foundation models are ML models, some concepts are relevant to working with both. If a topic is relevant to AIE but has been discussed extensively in DMLS, it'll still be covered in this book, but to a lesser extent, with pointers to relevant resources. Note that many topics are covered in DMLS but not in AIE, and vice versa. The first chapter of this book also covers the differences between traditional ML engineering and AI engineering. A real-world system often involves both traditional ML models and foundation models, so knowledge about working with both is often necessary. Preface 13. Determining whether something will last, however, is often challenging. I relied on 3 criteria. First, for a problem, I determined whether it results from the fundamental limitations of how AI works or if it'll go away with better models. If a problem is fundamental, I'll analyze its challenges and solutions to address each challenge. I'm a fan of the start simple approach, so for many problems, I'll start from the simplest solution and then progress with more complex solutions to address rising challenges. Second, I consulted an extensive network of researchers and engineers, who are smarter than I am, about what they think are the most important problems and solutions. Occasionally, I also relied on Lindy's law, which infers that the future life expectancy of a technology is proportional to its current age. So if something has been around for a while, I assume that it'll continue existing for a while longer. In this book, however, I occasionally included a concept that I believe to be temporary because it's immediately useful for some application developers or because it illustrates an interesting problem-solving approach. What this book is not: this book isn't a tutorial. While it mentions specific tools and includes pseudocode snippets to illustrate certain concepts, it doesn't teach you how to use a tool. Instead, it offers a framework for selecting tools. It includes many discussions on the trade-offs between different solutions and the questions you should ask when evaluating a solution. When you want to use a tool, it's usually easy to find tutorials for it online. AI chatbots are also pretty good at helping you get started with popular tools. This book isn't an ML theory book. It doesn't explain what a neural network is or how to build and train a model from scratch. While it explains many theoretical concepts immediately relevant to the discussion, the book is a practical book that focuses on helping you build successful AI applications to solve real-world problems. While it's possible to build foundation model-based applications without ML expertise, a basic understanding of ML and statistics can help you build better applications and save you from unnecessary suffering. You can read this book without any prior ML background. However, you will be more effective while building AI applications if you know the following concepts: probabilistic concepts such as sampling, determinism, and distribution. ML concepts such as supervision, self-supervision, log likelihood, gradient descent, backpropagation, loss function, and hyperparameter tuning. 14. Preface. Various neural network architectures, including feed-forward, recurrent, and transformer. Metrics such as accuracy, F1, precision, recall, cosine similarity, and cross-entropy. If you don't know them yet, don't worry, this book has either brief, high-level explanations or pointers to resources that can get you up to speed. Who this book is for? This book is for anyone who wants to leverage foundation models to solve real-world problems. This is a technical book, so the language of this book is geared toward technical roles, including AI engineers, ML engineers, data scientists, engineering managers, and technical product managers. This book is for you if you can relate to one of the following scenarios: you're building or optimizing an AI application, whether you're starting from scratch or looking to move beyond the demo phase into a production-ready stage. You may also be facing issues like hallucinations, security, latency, or costs, and need targeted solutions. You want to streamline your team's AI development process, making it more systematic, faster, and reliable. You want to understand how your organization can leverage foundation models to improve the business's bottom line and how to build a team to do so. You can also benefit from the book if you belong to one of the following groups: tool developers who want to identify underserved areas in AI engineering to position your products in the ecosystem, researchers who want to better understand AI use cases, job candidates seeking clarity on the skills needed to pursue a career as an AI engineer, anyone wanting to better understand AI's capabilities and limitations, and how it might affect different roles. I love getting to the bottom of things, so some sections dive a bit deeper into the technical side. While many early readers like the detail, it might not be for everyone. I'll give you a heads up before things get too technical. Feel free to skip ahead if it feels a little too in the weeds. Preface 15. Navigating this book is structured to follow the typical process for developing an AI application. Here's what this typical process looks like and how each chapter fits into the process. Because this book is modular, you're welcome to skip any section that you're already familiar with or that is less relevant to you. Before deciding to build an AI application, it's necessary to understand what this process involves and answer questions such as: is this application necessary? Is AI needed? Do I have to build this application myself? The first chapter of the book helps you answer these questions. It also covers a range of successful use cases to give a sense of what foundation models can do. While an ML background is not necessary to build AI applications, understanding how a foundation model works under the hood is useful to make the most out of it. Chapter 2 analyzes the making of a foundation model and the design decisions with significant impacts on downstream applications, including its training data recipe, model architectures and scales, and how the model is trained to align to human preference. It then discusses how a model generates a response, which helps explain the model's seemingly baffling behaviors, like inconsistency and hallucinations. The generation setting of a model is also often a cheap and easy way to signify can't boost the model's performance. Once you've committed to building an application with foundation models, evaluation will be an integral part of every step along the way. Evaluation is one of the hardest, if not the hardest, challenges of AI engineering. This book dedicates 2 chapters, chapters 3 and 4, to explore different evaluation methods and how to use them to create a reliable and systematic evaluation pipeline for your application. Given a query, the quality of a model's response depends on the following aspects: outside of the model's generation, setting the instructions for how the model should behave, the context the model can use to respond to the query, the model itself. The next 3 chapters of the book focus on how to optimize each of these aspects to improve a model's performance for an application. Chapter 5 covers prompt engineering, starting with what a prompt is, why prompt engineering works, and prompt engineering best practices. It then discusses how bad actors can exploit your applica tie-in with prompt attacks and how to defend your application against them. Chapter 6 explores why context is important for a model to generate accurate responses. It zooms into 2 major application patterns for context construction, RAG and agentic. The RAG pattern is better understood and has proven to work well in 16 preface production. On the other hand, while the agentic pattern promises to be much more powerful, it's also more complex and is still being explored. Chapter 7 is about how to adapt a model to an application by changing the model itself with fine-tuning. Due to the scale of foundation models, native model fine-tuning is memory-intensive, and many techniques are developed to allow fine-tuning better models with less memory. The chapter covers different fine-tuning approaches, supplemented by a more experimental approach, model merging. This chapter contains a more technical section that shows how to calculate the memory footprint of a model. Due to the availability of many fine-tuning frameworks, the fine-tuning process itself is often straightforward. However, getting data for fine-tuning is hard. The next chapter is all about data, including data acquisition, data annotations, data synthesis, and data processing. Many of the topics discussed in Chapter 8 are relevant beyond fine-tuning, including the question of what data quality means and how to evaluate the quality of your data. If Chapters 5 to 8 are about improving a model's quality, Chapter 9 is about making its inference cheaper and faster. It discusses optimization both at the model level and inference service level. If you're using a model API, i.e., someone else hosts your model for you, this API will likely take care of inference optimization for you. However, if you host the model yourself, either an open-source model or a model developed in-house, you'll need to implement many of the techniques discussed in this chapter. The last chapter in the book brings together the different concepts from this book to build an application end-to-end. The second part of the chapter is more product-focused, with discussions on how to design a user feedback system that helps you collect useful feedback while maintaining a good user experience. I often use we in this book to mean you, the reader, and I. It's a habit I got from my teaching days, as I saw writing as a shared learning experience for both the writer and the readers. Conventions used in this book. The following typographical conventions are used in this book. Italic indicates new terms, URLs, email addresses, file names, and file extensions. Preface 17. Constant with used for program listings, as well as within paragraphs to refer to program elements such as variable or function names, databases, data types, environment variables, statements, input prompts into models, and keywords. Constant with bold shows commands or other text that should be typed literally by the user. Constant with italic shows text that should be replaced with user-supplied values or by values determined by context. This element signifies a tip or suggestion. This element signifies a general note. This element indicates a warning or caution. Using code examples, supplemental material, code examples, exercises, etc., is available for download at https://github.com/chiphuyen/AI-ebook. The repository contains additional resources about AI engineering, including important papers and helpful tools. It also covers topics that are too deep to go into in this book. For those interested in the process of writing this book, the GitHub repository also contains behind-the-scenes information and statistics about the book. If you have a technical question or a problem using the code examples, please send email to support@o'Reilly.com. This book is here to help you get your job done. In general, if example code is offered with this book, you may use it in your programs and documentation. You do not need to contact us for permission unless you're reproducing a significant portion of the code. For example, writing a program that uses several chunks of code from 18. Preface. This book does not require permission. Selling or distributing examples from O'Reilly Books does require permission. Answering a question by citing this book and quoting example code does not require permission. Incorporating a significant amount of example code from this book into your product's documentation does require permission. We appreciate, but generally do not require, attribution. An attribution usually includes the title, author, publisher, and ISBN. For example, AI Engineering by Chip Huyen, O'Reilly. Copyright 2025 Developer Experience Advisory LLC, 978-1-098-16630-4. If you feel your use of code examples falls outside fair use or the permission given above, feel free to contact us at permissions@o'reilly.com. O'Reilly Online Learning. For more than 40 years, O'Reilly Media has provided technology and business training, knowledge, and insight to help companies succeed. Our unique network of experts and innovators share their knowledge and expertise through books, articles, and our online learning platform. O'Reilly's online learning platform gives you on-demand access to live training courses, in-depth learning paths, interactive coding environments, and a vast collection of text and video from O'Reilly and 200+ other publishers. For more information, visit https://o'reilly.com. How to contact us. Please address comments and questions concerning this book to the publisher, O'Reilly Media Incorporated. 1005, Gravenstein Highway, North Sebastopol, California, 95472-800-889-8969, in the United States or Canada, 707-827-7019, international or local, 707-829-0104, fax, support@O'Reilly.com. https://o'reilly.com/about/contact. HTML. We have a web page for this book, where we list errata, examples, and any additional information. You can access this page at https://o'reilly.ly/AI Engineering. Preface 19. For news and information about our books and courses, visit https://o'reilly.com. Find us on LinkedIn, https://linkedin.com/company/O'Reilly Media. Watch us on YouTube, https://youtube.com/O'Reilly Media. Acknowledgements. This book would have taken a lot longer to write and missed many important topics if it wasn't for so many wonderful people who helped me through the process. Because the timeline for the project was tight, 2 years for a 150,000-word book that covers so much ground, I'm grateful to the technical reviewers who put aside their precious time to review this book so quickly. Luke Metz is an amazing soundboard who checked my assumptions and prevented me from going down the wrong path. Hancheng Lee, always up to date with the latest AI news and community development, pointed me toward resources that I had missed. Luke and Han were the first to review my drafts before I sent them to the next round of technical reviewers, and I'm forever indebted to them for tolerating my follies and mistakes. Having led AI innovation at Fortune 500 companies, Vittorio Cretella and Andrei Lopatenko provided invaluable feedback that combined deep technical expertise with executive insights. Vicky Raiselman helped me ground my content and keep it relevant for readers with a software engineering background. Eugene Yen, a dear friend and amazing applied scientist, provided me with technical and emotional support. Sean Wang, SWYX, provided an important vibe check that helped me feel more confident about the book. Sanyam Bhutani, one of the best learners and most humble souls I know, not only gave thoughtful written feedback but also recorded videos to explain his feedback. Kyle Cronin is a star deep learning lead who interviewed his colleagues and shared with me an amazing write-up about their fine-tuning process, which guided the fine-tuning chapter. Mark Sarufim, an inquisitive mind who always has his finger on the pulse of the most interesting problems, introduced me to great resources on FE Sciency. Both Kyle and Mark's feedback was critical in writing chapters 7 and 9. Kitapatbot Kampa, in addition to answering my many questions, shared with me a detailed visualization of how he thinks about AI platforms. I appreciate Dennis Linkoff's systematic approach to evaluation and platform development. Chayden Tecker gave great examples that helped me structure AI application patterns. I'd also like to thank Xingji, Alex, Lee and Hien Liu for their thoughtful feedback on my draft on AI architecture. XX, Preface. Aileen Bui is a treasure who shared unique feedback and examples from a product manager's perspective. Thanks to Todor Markov for the actionable advice on the RAG and agents chapter. Thanks to Tal Catchman for jumping in at the last minute to push the fine-tuning chapter over the finish line. There are so many wonderful people whose company and conversations gave me ideas that guided the content of this book. I tried my best to include the names of everyone who has helped me here, but due to the inherent faultiness of human MEM-ORI, I undoubtedly neglected to mention many. If I forgot to include your name, please know that it wasn't because I don't appreciate your contribution, and please kindly remind me so that I can rectify this as soon as possible. Andrew Francis, Anish Nag, Anthony Galczak, Anton Bakaj, Balash Galambosi, Charles Fry, Charles Packer, Chris Brousseau, Eric Hartford, Goku Mohandas, Hamal Hussain, Harpreet Sahota, Hassan Elmgari, Huyen Nguyen, Jeremy Howard, Jesse Silver, John Cook, Juan Pablo Bataro, Kyle Gallatin, Lance Martin, Lucio Derry, Matt Ross, Maxime Laban, Miles Brundage, Nathan Lambert, Omar Khattab, Fong Nguyen, Purnendu Mukherjee, Sam Reiswig, Sebastian Rashka, Shahul Es, Sharif Shamim, Somith Chintala. Technium, Tim Detmers, Undi 95, Val Andre Fajardo, Vern Leong, Victor San, Wing Lian, Shichuan Chui, Ying Xing, and Christopher. I'd like to thank all early readers who have also reached out with feedback. Douglas Bailey is a super reader who shared so much thoughtful feedback. Thanks to Newton Sahu for suggesting an elegant way to explain perplexity. I learned so much from the online discussions with so many. Thanks to everyone who's ever answered my questions, commented on my posts, or sent me an email with your thoughts. Of course, the book wouldn't have been possible without the team at O'Reilly, especially my development editors, Melissa Potter, Corbin Collins, Jill Leonard, and my production editor, Elizabeth Kelly. Liz Wheeler is the most discerning copy editor I've ever worked with. Nicole Butterfield is a force who oversaw this book from an idea to a final product. This book, after all, is an accumulation of invaluable lessons I learned throughout my career. I owe these lessons to my extremely competent and patient coworkers and former coworkers. Every person I've worked with has taught me something new about bringing ML into the world. Preface 21. Chapter 1 Introduction to Building AI Applications with Foundation Models. If I could use only one word to describe AI post-2020, it'd be scale. The AI models behind applications like ChatGPT, Google's Gemini, and Midjourney are at such a scale that they're consuming a non-trivial portion of the world's electricity, and we're at risk of running out of publicly available internet data to train them. The scaling up of AI models has two major consequences. First, AI models are becoming more powerful and capable of more tasks, enabling more applications. More people and teams leverage AI to increase productivity, create economic value, and improve quality of life. Second, training large language models, LLMs, requires data, compute resources, and specialized talent that only a few organizations can afford. This has led to the emergence of model as a service. Models developed by these few organizations are made available for others to use as a service. Anyone who wishes to leverage AI to build applications can now use these models to do so without having to invest upfront in building a model. In short, the demand for AI applications has increased while the barrier to entry for building AI applications has decreased. This has turned AI engineering, the process of building applications on top of readily available models, into one of the fastest growing engineering disciplines. Building applications on top of machine learning, ML, models isn't new. Long before LLMs became prominent, AI was already powering many applications, including product recommendations, fraud detection, and churn prediction. While many principles of productionizing AI applications remain the same, the new generation of one in this book, I use traditional ML to refer to all ML before foundation models. Large-scale, readily available models brings about new possibilities and new challenges, which are the focus of this book. This chapter begins with an overview of foundation models, the key catalyst behind the explosion of AI engineering. I'll then discuss a range of successful AI use cases, each illustrating what AI is good and not yet good at. As AI's capabilities expand daily, predicting its future possibilities becomes increasingly challenging. However, existing application patterns can help uncover opportunities today and offer clues about how AI may continue to be used in the future. To close out the chapter, I'll provide an overview of the new AI stack, including what has changed with foundation models, what remains the same, and how the role of an AI engineer today differs from that of a traditional ML engineer. The rise of AI engineering. Foundation models emerged from large language models, which, in turn, originated as just language models. While applications like ChatGPT and GitHub's Copilot may seem to have come out of nowhere, They are the culmination of decades of technology advancements, with the first language models emerging in the 1950s. This section traces the key breakthroughs that enabled the evolution from language models to AI engineering. From language models to large language models. While language models have been around for a while, they've only been able to grow to the scale they are today with self-supervision. This section gives a quick overview of what language model and self-supervision mean. If you're already familiar with those, feel free to skip this section. Language models. A language model encodes statistical information about one or more languages. Intuitively, this information tells us how likely a word is to appear in a given context. For example, given the context, my favorite color is __, a language model that encodes English should predict blue more often than car. 2. Chapter 1, Introduction to Building AI Applications with Foundation Models. 2. For non-English languages, a single Unicode character can sometimes be represented as multiple tokens. The statistical nature of languages was discovered centuries ago. In the 1905 story, The Adventure of the Dancing Men, Sherlock Holmes leveraged simple statistical information of English to decode sequences of mysterious stick figures. Since the most common letter in English is E, Holmes deduced that the most common stick figure must stand for E. Later on, Claude Shannon used more sophisticated statistics to decipher enemies' messages during the Second World War. His work on how to model English was published in his 1951 landmark paper, Prediction and Entropy of Printed English. Many concepts introduced in this paper, including entropy, are still used for long-gauge modeling today. In the early days, a language model involved one language. However, today, a long-gauge model can involve multiple languages. The basic unit of a language model is token. A token can be a character, a word, or a part of a word, like tie-in, depending on the model. 2. For example, GPT-4, a model behind ChatGPT, breaks the phrase "I can't wait to build AI applications" into 9 tokens, as shown in Figure 1.1. Note that in this example, the word can't is broken into 2 tokens, can and t. You can see how different OpenAI models tokenize text on the OpenAI website. Figure 1.1. An example of how GPT-4 tokenizes a phrase. The process of breaking the original text into tokens is called tokenization. For GPT-4, an average token is approximately 3/4 the length of a word. So, 100 tokens are approximately 75 words. The set of all tokens a model can work with is the model's vocabulary. You can use a small number of tokens to construct a large number of distinct words, similar to how you can use a few letters in the alphabet to construct many words. The Mixtral 8x7b model has a vocabulary size of 32,000. GPT-4's vocabulary size is 100,256. The tokenization method and vocabulary size are decided by model developers. The rise of AI engineering. 3. Autoregressive language models are sometimes referred to as causal language models. Why do language models use token as their unit instead of word or character? There are 3 main reasons. 1. Compared to characters, tokens allow the model to break words into meaningful components. For example, cooking can be broken into cook and ing, with both components carrying some meaning of the original word. 2. Because there are fewer unique tokens than unique words, this reduces the model's vocabulary size, making the model more efficient, as discussed in Chapter 2. 3. Tokens also help the model process unknown words. For instance, a made-up word like chatting could be split into chat and ing, helping the model understand its structure. Tokens balance having fewer units than words while retaining more meaning than individual characters. There are 2 main types of language models, masked language models and autoregressive language models. They differ based on what information they can use to predict a token. Masked language model. A masked language model is trained to predict missing tokens anywhere in a sequence, using the context from both before and after the missing tokens. In essence, a masked language model is trained to be able to fill in the blank. For example, given the context, my favorite __ is blue, a masked language model should predict that the blank is likely color. A well-known example of a masked language model is bidirectional encoder representations from transformers, or BERT, Devlin et al., 2018. As of writing, masked language models are commonly used for non-generative tasks such as sentiment analysis and text classification. They are also